Welcome to CW 1.5. Today we're going to be talking about quadratic inequalities. So to do this, I'm going to show you one primary method. And it is going to take a little bit of time. Once you get used to it, this is a very, very good method to know. This method is called creating a sine chart. Now to do this method, all we got to do is take that quadratic, we're going to factor it. So that would be x minus 6, x plus 2, less than equal to 0. Now what we're going to do is note where this thing is equal to 0. So I'll write z for zeros, and I'll note the zeros are 6 and negative 2. Meaning if I plug in 6 here, you get 0. You plug in negative 2 here, you get 0. Now from there, we're going to make what's called a sine chart. So to do that, you first make a line like this. And what that is it's a number line. Okay, so this is a number line. And you put the zeros in order. Meaning negative 2 should be right about here. And then 6 will be about here. Now, it doesn't really matter where it is as long as it's in the correct order. So negative 2 should come before 6. Now what you do is from your zeros, you're going to drop a dotted line like that. Dotted line. So what we're doing is we're separating all the numbers into 3 regions. The numbers here are less than negative 2. The numbers here are between negative 2 and 6. The numbers here are greater than 6. So that represents every region that could happen in this scenario. Now over here on the far left, we're going to write the factors, meaning this part. So you're going to write x minus 6, x plus 2, like that. Now this is the part where you're going to just plug in numbers and figure out if it's positive or negative. That's why it's called a sine chart, because you're checking the sign of each expression. So for example, for this one, we want to plug in a number that's less than negative 2. So let's say I plug in negative 4. Imagine you plug in negative 4 right there. Negative 4 minus 6. You don't have to calculate that. Just think if it's positive or negative. We can see that's clearly going to be a negative number. So you write a negative right there. Now you plug in that same number, negative 4, to this one. Negative 4 plus 2. Notice how that's still negative, so you put negative there. So all we're doing is we're saying if the number is less than negative 2, you plug it in here, the outcome is negative. Plug it in here, outcome is negative. Now we go to the region in the middle. A good number here would be 0. So let's pick 0. If you plug in 0 to this thing, 0 minus 6, notice how that's negative. So again, put another negative. 0 plus 2 into this one would be positive. So put positive. And for the last region, pick a number greater than 6. Let's say you pick like 10. So notice how if you plug in 10 to each of these, the outcome should be positive. Now here's the most important part. These 3 dots mean therefore. Hopefully you've seen that in geometry. This is called the therefore row. So notice how these 2 expressions are being multiplied. So what we want to do is multiply the signs together in their respective column. So negative times negative, that would be positive. Negative times positive, that's negative. And positive times positive is a positive. So this here, the blue row, is the one we want to focus on. So now we look at the original question. We're looking for when this thing, notice how it says less than or equal to 0. So what you want to do is look here and think, okay, positive, negative, positive. What sign is less than 0? That's your negative sign. So right here is your answer. So we're going to write an interval negative 2 to 6. Because it's equal to, we're going to close the interval. And right there is your answer. And I put another one over here, so you can try on your own later. I'll put the answer there. So you can just try that on your own later if you want more practice on that. We'll do one more example of a sine chart here though. Notice how for this problem, it's not quite as straightforward as the last one. This one we had a 0 there, so we can just straight up factor it. In this particular problem, there's no 0. So what you have to do is create the situation where there is a 0. So imagine that this line is our expression. We want this to happen. We want our expression to have a 0 on it. So before we start factoring, think of this as your goal. So let's algebraically manipulate that. That would be 2x squared minus x minus 10 is less than 0. Once you have this 0 here on one of the sides, now you factor. Okay, so let's factor that. We're going to write 2x and x. Hopefully you remember factoring from your last Algebra 2 class. This should be 5 and 2 minus and plus. From here, we're going to find the zeros. That would be 5 over 2, negative 2. Let's make our number line. And now that we've done it once, hopefully this is a little more fluid. Negative 2 comes first. 5 over 2 comes second. Let's plug in our expression here. And then, of course, our therefore row. And let's see if we can do it fast. In this column, let's pick a big negative number like, I don't know, negative 10 maybe. Plug in negative 10 to each of these. We can see that they're both negative. You multiply two negatives, you get a positive. Let's pick 0 again in the middle. So this should be negative, positive. Outcome would be negative. And something bigger than 5 over 2, like 10, we can see they're both positive. So the outcome is positive. And once again, we can see that this thing right here is less than 0, which means we want the negatives. So we circle that. So notice how it's quite similar to our last question, except there's no equal to, so notice how I put parentheses here. Now, if it were greater than, like let's say it was the other way, in that case, you take the positive answer. So because it's less than, we want the negative answers. Okay, so that's our first example with the sine chart. Now we'll do a couple more with the graph now. So now I have the same idea, except notice how it's graphical. So we have f of x is less than g of x. So f of x is the blue. So here's the blue graph, the parabola. G of x is this pink one. So I'll put this in pink. If you see less than right here, f of x less than g of x, think of it as the word under. It's saying, where is the blue line under the pink line? So if I highlight that, I can see all of this stuff. That's where the blue line is under the pink line. Now to write the answer, we're going to use the x values. That's because we're comparing the value of the y values. So when we say the word under, we're saying the y values here are under the y values on this one. So look at the x values here, and that's what you use to write your answer. Negative 2 to 5 over 2. There's no equal to, so use parentheses. Okay, next one. So if less than meant under, this must mean over. Where's f of x over? Or you can think of it as above, maybe. That might be a better word for us. Where is it above the pink line? And I'll highlight that in yellow maybe. That's all over here. So that's going to be negative infinity to negative 2, inclusive since it's equal to, union with 5 over 2 to infinity. So that's just the interval around it. So notice how when it was under, we wanted this part. When it was over or above, we wanted the outside part. Okay, here's our last example. So don't worry, this is the same thing, just sign switched. So this one's pretty fast. Solve this inequality. So your first instinct is going to be to factor, but notice how if you try to factor, this is not going to work. So in the event you can't factor, that means something fishy is happening. What we're going to do is go to the quadratic formula. And we're going to see if something happens. So x equals opposite b, negative 1 plus minus the square root of b squared minus 4 ac all over 2a. What you want to do is notice right here, this part is called the discriminant. And notice how this number is less than 0. That means there's no solution here if I were to solve that. And what that translates to is that there is no x-intercept. So this is what we were looking for. That's very important. So remember our last chapter we said, or last unit, this thing's a positive x squared. So if I told you to sketch that in your mind, we know that's an upwards parabola. If there's no x-intercept, that means the graph should look something like this. It doesn't hit the x-axis. So that's how we're going to solve this. This thing says, where is it greater than 0? Well, this graph is always above 0. Because if you think about 0, this is your y equals 0 line. It never hits it, so it's always above it. Therefore, the answer is all real numbers. And that's a symbol for all real numbers. And for the other one, notice how it's the same thing, just less than 0. So this graph, it'd be like asking, where is this graph under the x-axis? And it would be never. There is no solution here. It is never under the x-axis. Okay, so that's it. Let's work on some practice problems.